I thought I'd put a title on this, and this is just, I call it Teaching and Researching at UQ. As you may be aware, I've been at UQ for quite some time. If you want to look up details about what areas, what papers I've been working on, etc., well, my homepage down here carries it has a lot of information on it. And also,
I think our third speaker. Yeah, he's here. Hey, Jason, can you hear us?
Yeah, I can. Can you hear me?
Yes. I think Geoff just started his talk, and then we will introduce you in around 30 minutes. So you will say hello to the audience later on, okay?
Okay, that's fine.
Yeah, okay, thanks. Sorry.
Yeah, that's okay. So I was asked to speak on these 4 points, and I'll say a few words, particularly about the first few, and see how we're going for time. Just a little bit of history, and I'll start off with this married couple, Mildred and Sid Prentice. Sid Prentice was Professor of Electrical Engineering here back in the 60s, and that's going back a little bit, I know, for some of you. And he was responsible for getting the first mainframe computer at this university. And as you can imagine, in those days they were big as a big two-door fridge. And we used to do computing by having punch cards and taking them across to the Prentice Centre. But of more relevance to us, his wife Mildred, she had a lectureship in statistics in the maths department, where the statistics was in the maths department, and the maths department now is in a school of maths and physics. And Mildred Prentice, she was this person called M.M. Barnard, and she wrote this paper back in 1935, and she did a PhD under the famous Fisher. If you do anything about statistics, you would know that R.A. Fisher is the father of modern day statistics. He was a genius. He responsible for the concept of randomization to reduce bias in any experiment. His work was done in an agricultural setting in Rothamsted, but in clinical trials or anything, he pioneered the idea of randomization, and of course he put forward maximum likelihood that we still use today. So what was unusual about this was, first of all, she was a female being there doing a PhD, and it was unusual for people to do PhDs back in those days. And of course, doing a PhD under Fisher, well, she could have got any job she wanted in the world, really. She would have. But when she came back to Australia, I think she worked perhaps for CSIRO for a while, but then when she had children, and so she never really worked again until she came back to UQ to do some lecturing. And she had some but she had some interesting stories to tell about Fisher. And because Fisher was a fairly prickly character not for her, and naturally she was showing respect, but for anyone Fisher viewed as being not a competitor, but if anyone was a bit said anything slightly disparaging about his work, he was extremely, he could get pretty mad. But, and so Fisher had a number of children. He had a daughter called Joan. She married a famous statistician. She married George Box, who became a famous statistician. You got the Box-Cox transformation. They later divorced, but Jane Box wrote a biography of Fisher. And she came to Brisbane a few times to visit Mildred. Mildred also knew Betty Cochrane, the wife of Bill Cochrane. He was the author of Cochrane and Cox. He was you might say, famous statistician, and he spent the last part of his life being head of statistics at Harvard. Brad Efron, who was perhaps one of the most highly regarded statisticians today, told me that Cochrane was never wrong, but obviously that's not completely true. Then when Joe Garney became head of Maths and Stats at CSIRO, he's actually born in Egypt, but he spent most of his younger days in Australia, and then he went overseas and became a professor at Sheffield. When he came back to Australia to head CSIRO, Maths and Stats, he brought a lot of people out here. We had Sir David Cox, Sir John Kingman, Morris Bartlett, John Nelder, all these famous names in statistics, and then some Americans. Well, John Tukey and Ted Anderson. John Hartigan was an Australian, but he had gone to become professor at Yale, and he really never came back except to visit us. So, although you might think doing statistics here at UQ, we're sort of isolated perhaps from the rest of the world, we felt that we knew what was going on due to the stream of visitors that we had. Also, I did my honours degree here, and I suppose I specialised in statistics and pure maths. I didn't really like applied maths, fluid dynamics. I actually found it very difficult, so I was... but I liked statistics, and also it did have the option that if I didn't really make it in academia, I could get a job working for CSIRO or the government department, such as whatever it was called, Department of Primary Industries or Department of Agriculture. And so I did a PhD, and I did it in discriminant analysis. You can see the title of the thesis there. I wasn't trying to follow in Mildred's footsteps, but it came about because, well, when you're a PhD student, you basically not completely sure. I wasn't really sure what problem I'd work on, and there was this really nice paper that came out around about 10 years before I started my PhD, and so I got reading it, and I could see that perhaps I could do some original research. But that's always an unknown question. I think anyone, doesn't matter how well they do in the exams, when it comes to doing a thesis, you're in mathematics or statistics. You always wonder, just how you're going to go. But these days there's more scope. You can do more of an applied statistic. You can do extensive simulations. Back in '73, you had to do a solid piece of mathematics to get a PhD in statistics. So basically I've been at UQ, been employed by UQ most of my working life. So in '73, I got my PhD. I was married. We had a home unit in Brisbane, and on the river, but it didn't have a river view. We're on the roadside, but and I was a tutor, but I really needed the job, and there was a hint that might be a job for me here in 1 or 2 years. So I was offered a lectureship at the University of New England, and while I was going there, I was offered a job at the University of New South Wales, but I decided to go to the University of New England. But as we were packing up to leave to go to the University of New England, Brisbane had this tremendous flood in '74, and we were sitting in our unit watching the water come up one desert block at a time, and my father told me, "Don't worry, as water rises, it spreads." But it just kept coming up, and it came about 2 feet into our unit. But because it was a big block of units, we rolled up the carpet before the water came in and took everything up sort of stairs. So, and then we left it, when the water went down, we left for New England, for Armidale, and it was a tenant's problem really then. So we got someone in to clean the place up, put the carpet back. But, so anyway, the University of New England had a big stats department, and we were quite happy there, apart from the cold. And but rather fortuitously for me, a young professor from India decided he would go back to India, and so a position came up, and so I got reappointed from the 31st of December '74. Now, but although you must say it's fairly interesting remaining at the same place, I did spend 6 months at Stanford. We had a 9-week-old baby, so my wife was a little bit apprehensive going as our first child, but it was very well. Stanford is a very nice campus. It's got its really own shopping centre, and you wouldn't know what was going on in the rest of America. And but what was really good is, of course, it's got, at that time it was ranked #1 jointly with Berkeley, and since then it's always been ranked #1 in statistics. And they had lots of professors there. It used to have joint seminars with Berkeley. People like Jerzy Neyman, he was still alive, but used to come to the seminars. And I drove to Berkeley for a seminar at Berkeley. That day there was someone on the Bay Bridge shooting at people as they went across the bridge, but there was, they didn't get my car anyway. But so I got to know a lot of people. The head of department, Paul Switzer, had us out for Thanksgiving Day, and when he came to Brisbane, he stayed at our place. And so I got to know people like Brad Efron, and then I kept up these acquaintances because I started to travel quite a bit. And my younger son keeps reminding me that I wasn't there for his first birthday. But anyway, so although I've been here employed at UQ, I sort of I'm aware of what's going on in the rest of the world and know a lot of statisticians. So supervised classification, I mentioned I did my PhD in that area, and so this is what we mean by supervised classification. And we sort of got 2 classes. You've got data from each of the classes, and how do you estimate the error rate? Well, in the ideal world, you've got what we call a training set, and then it's separated, if you like, by a brick wall that doesn't come into it. And it doesn't allow you to test the test set until you go to test the thing. But unfortunately, these days particularly, you may have only a few samples with microarrays, because each microarray originally started costing, I think, $10,000. Now it's down to a few $100s. So, but anyway, so this is in an ideal world to have this holdout sample, but that doesn't often happen. And I started to write a book because I collected a lot of references during my thesis, and this book had 1,300 references in it. Now, so what's one particular problem that I worked on besides error rate estimation, and it's called selection bias, and it's you can read what it is there. The main thing is, if you use the data to build some rule or some classifier, then you've got to be careful using that data to work out its error rate. And Christophe Ambros came from Paris to work with me, and his wife had just had a baby and 2 other children, and Brisbane in those days seemed to have a terrible summer. Probably no hotter now than our summers, but they've never been back to Brisbane because they didn't have air conditioning, and they lived in a small house in Milton. But I'm good friends with Christophe and his wife, Martine, but we see them in Paris, not here. But this is an example. So this is one of my most cited papers in statistics. These authors here, this Batnick is a famous scientist, computer scientist, and I don't think he could have read this paper really, but they devised this method of how to reduce the number of variables, and they claim that there's a lot in this diagram, and there's a lot in this diagram, but basically they said that if they if you read this diagram from right to left, they said if you keep reducing the number of variables down, you get to basically a 0 error rate. Whereas the true error rate is that solid line there with the error bars around it. So that was a big error, and we were lucky to find that error. And now you might say, well, that was 2002, but here's the paper in 2016 in a fairly good journal pattern recognition letters, and it's making the same mistake. This is supposed to be the error rate dropping down almost to nothing really as they increase the number of variables, and that there's a selection bias here. I was actually at this seminar when the person gave it. Now, how did I get into unsupervised work? Well, as I said, there's a very nice paper on supervised classification by Hills, and one of the it was a red paper, so someone discussed it, C.A.B. Smith. He was a well-known statistician, and he suggested that why not go about dividing a sample up and doing these things. He uses the word bootstrap. You recall later on, Efron in 79 called his method the bootstrap. So I set about having a look at this problem, but I really cheated. I couldn't handle a completely unsupervised sample, so I introduced some observations having labels to make the mathematics equal. Not equal, now enabling me to do it, and so I came up with this result here that this gives you the error rate after k iterations, and the idea is the error rate is supposed to go. Now to work, unfortunately. The error rate is supposed to go down. It will if these terms h1 and h2 are less than 1. This is one of my favourite results actually. But when you're putting in the grant and they ask you to put in one of your nice regards, you can't put a result that you've done in 1975 because they say, oh, this person, he's peaked and he's done nothing for the last few years or something. But this, I think, it's a result that I like very much. But, and of course then the EM algorithm came along and that really got people's interest in mixture models going, and this is a definition of a mixture model. And I'm just putting the definition up. I know this is not a seminar, but instead of having a single component, we take a linear combination of them, and it's a convex combination because those pi ones, the pi g there, the constants, they're non-negative and they sum to 1. So you get a lot of flexibility, and for example, you can see that you've got the potential to have a very flexible way of estimating densities. So I think Kay was about my third PhD student, and so she worked on mixture models, and I think at the time when it came for her to submit her thesis, she had about 5 or 6 papers, so the examination process was quite straightforward, and Kay got her PhD, and then a year or two later we decided we'd write a book, and I was fortunate enough to be in Scotland at the time because Michael Titrington, a well-known statistician, was bringing out a book, and we sort of, and so I knew what he was talking on, and our book was more about, rather than the properties, it was trying to push the idea that there was potential to use mixture models to cluster data, and so now Larry Wasserman, who's a well-known statistician, he's a member of the US National Academy of Sciences, he used to have a blog, and he wrote that mixture models is the twilight zone of statistics. And he's got this comment down here that they come up all the time and they're obviously very useful, yet they're a strange beast. So a lot of people were put off by their unusual properties, or they can have unusual properties. So I think that this book went some way to making people aware of the practical potential of using mixture models, and that's the cover of the book. Oh, and talking about writing books, of course, Kay has written a book with a much more distinguished person than myself, and namely John Tukey, because John Tukey is a famous scientist. Besides things in statistics, he coined the word software, the word bit that you use in computing. There's a person from India called 3M Bakam Krishnan. He liked to be called Krish, and fortunately for us, with a Christian name like that, he came to Brisbane to see me about writing a book on the EM algorithm. I think also he wanted to come to the Brisbane cricket ground because he loved cricket. And but anyway, he while he was here, he wrote many letters to the Australian about how umpires. We didn't have neutral umpires in those days, and how they weren't really being neutral in their decision. So he had a student called Sumya Dr. Pine. He likes to be called Pine. And he was at the Broad Institute, which is a joint institute of MIT and Harvard. And he wrote to me, he wanted me to have a look at fitting mixtures of skew distributions because when they looked at these, the data on these markers on cells as they were passed through a beam, they didn't have an elliptically symmetric shape. And even when they were cultured in a laboratory, they still had this, and so this got us fitting mixture of skew distributions. And this slide is just a current problem that I'm working on. If you like, we've got two classes there, and each, this represents patient 1, patient 2, and they've got this distribution, and the population of their cells looks like it needs a 5-component mixture to model it. But these people aren't all the same, and they don't have identical distributions, but we want a representative distribution for the class. So we build a template for each class, and then someone comes along and we have to assign them to one of these two classes. And so we look at the pullback libel distance between the sample distribution and that of the templates, and then we can make a decision what to do. And we might want to, we know what some of these clusters represent. They could be memory T cells or naive T cells, and we might want to do things to them, stimulate some of them. And so by having the distribution represented by a mixture, it allows us to actually go further into it. Now I'm out of time, and I think that's about the last. Well, things from an employer's perspective, I would say that one should really try and do as much statistics and computing and as one has time for. The other thing I would say is I think you have to keep aware of what are some topics going on. In statistics, we've got some people from within not liking p-values. P-values are misused. Some people don't understand what a p-value is. But before we get rid of p-values, we need some other alternative. And so there's that taking place. And the other thing is, of course, is that from time to time we get a paper like this that comes out by a very respected epidemiologist and medical statistician, but it's sort of the thing that's being plotted here is the probability of a false positive, and obviously if the odds of a relationship are very low, because in statistics we're trying to make decisions in the presence of noise, we will make errors, and so as the odds get very small, then the chances of making a false positive will increase, and he's introduced some probability that a person, if they get a non-significant result, they'll change it into a significant one. So all this is just based on his reading of what these things should be. And there has been some criticism of this, and there's this paper, 2014, not that long ago, where they try to estimate what the false discovery rate would be from papers submitted to the top 5 journals in medicine, and they got the error rate to be about 14%. So, well, I think I've got way over time. So I'll stop there, and I think the last thing said, would I do anything differently? Well, I mean, of course you would do some things differently in hindsight, but I wanted to remain in Brisbane, not that I've got any great attachments to Brisbane, but once your children start going to a school, and it's very hard to move, and also the University of Queensland. I always thought the University of Queensland had been a good university. And it's gone from it's getting better. So, oh, I should say, statistics at UQ is the only department in Australia that's got the top rating in all the eras that have been conducted. Yeah. So.